Okay, let's go ahead and talk about this. What trials did you want to pick?
1 and 2.
Why 1 and 2?
Only one of them changes.
Only one of them changes. Okay, so A stays constant, so I know any change in my rate has nothing to do with A's with A. So I've got 0 change here. This goes up by 3. What does this do? Goes up by about 3. Okay, so what order is it with respect to B? First order, since it goes up by the same factor. Okay, how about A? Trials, which ones? So I go 1, this goes up by 2, this doesn't change at all, and this goes up by about 4. So then it's second order with respect to A. So then the rate law for this is going to be rate is equal to K, A to the second, B to the first. And the constant? What am I doing for the rate constant? Tyler?
Putting in the numbers for one of the trials.
Okay, so I'm going to solve for K. K is equal to rate divided by A squared times B. So I'll put in 2.2 divided by 0.4 squared times 0.2. I'm going to get something out of that. K equal to 70. You go with that?
You're just rounding, is that?
I only have one sig fig.
Oh, okay.
That was closer to 68 because one of the other trials brought me under to 67 point something.
That's still going to get me to 70.
Oh, right. Sig
figs. So we okay with that?
Uh-huh.
All right. Next one. So I don't know. We'll choose here and here. I got a 0 and I got a 3. And what happens here? Goes up by about 9. So 3 equal to 9 when this is a 2. Go with that. So second order with respect to the oxygen. All right. How about the hydrogen? So this goes up by 3. And this goes, no, don't want that one. Sorry. Oh, I was a jerk. This goes up by 3. This goes up by 2, and this goes up by 108. All right, 108. Awesome. So I got 108. How much of that is due to the oxygen? A factor of 4. How did I get a factor of 4? Not 2 times 2. Not 2 divided by 2. 2 squared. So I get 4 there. And then that leaves...
Where's the 2 squared coming from?
what
parts of this? Like, are you looking at the...
This 2 right here. I went from... What happened to the concentration here?
okay, 2 isn't it doubled?
2 isn't it doubled, and then we know that this guy's squared, right? So 2 squared.
Gotcha.
I would expect if I did this reaction and I had done this concentration change, I would expect the rate to go up by a factor of 4.
Yeah.
It went up by 108, so I have to pull the 4 out, leaving me with what? 27, is that right? Okay, so then the hydrogen is responsible for that 27 change. But what I had was 3 is equal to 27 when? 9? Okay.
Nothing.
When 3 is raised to the third power, are we okay with that? So tell me about the hydrogen. It's third order, right? Okay.
Yes.
What? What's wrong with that?
Just didn't get that.
Didn't get this at
I knew it
all.
was 2 at least. Come back. Must be God, so.
So then K would be equal to, I don't know, I'll just write 580, 4.5 cubed, and 2.0 squared. .59, so 1.6 for the K. Does that make sense? Okay, what do we got next? What do you want to write here?
Positive slope. End of it.
Positive slope. I
At
don't.
least for part of it.
I can't. Okay. At least for part of it. Okay.
Let's say anything. It goes up and to the right to be.
So I have a curve. I have some reactants, and then what happens?
And you add some energy.
I had some energy to do what?
Activation.
Activate. And then the energy of my products is more than the energy of my reactants. EA, and then delta G. This is energy, and this is progress. That look good? Doesn't work at all. It's ridiculous. Okay, so what were the 4 factors?
Substances, the nature of reactants, concentration of reactants, temperature, catalyst.
Okay, and the 3 parts to the collision theory? And so for them to collide, that's about the nature. So if I have a gas as opposed to a solid, they're more likely to run into each other. So that's about collisions. If I increase the concentration, they're more likely to collide with each other. If I increase the temperature, then they're going to have enough energy. And if I insert a catalyst, then they're more likely to be oriented correctly. You know with that? All right.